So today we're going to actually look at that quadratic formula and talk about how we can use it. So the quadratic formula says x equals negative b plus or minus long square root, because all the rest of this stuff is inside the square root, b squared minus 4ac, big long fraction bar. That's a big problem for a lot of my students. Make sure that fraction bar is including everything, all over 2a. Yes, Livia?
Is it going to say specifically use quadratic formula?
It will not specifically say that on your test.
So I can use whatever?
So you can use whatever you would like to use. However, the quadratic formula is the only one that works all the time. Okay, so the quadratic formula has no stipulations to it. It always works on any problem. Solving by taking a square root, right? We said we had a dilemma that we could only use it if there was no x to the first power. Factoring only worked if it was factorable. Completing the square, we had to get in the correct format to complete the square, right? So if we ended up with that sort of odd b or a fraction of a b, we weren't guaranteed to end up with a perfect square, so that didn't always work. Solving by graphing only works if we got something that we could visually see what those intercepts were exactly, right? If that intercept was 4.2731568, right, we were really talking about an irrational and we would have to approximate. Okay, the quadratic formula is going to work all the time. Now, for those of you yesterday who said, I'm okay with the other options, I like those other options, you might be deciding you're only going to use the quadratic formula when b is odd. Okay, when a is something other than 1, when you can't factor it. Okay, for those of you who did not like the other options yesterday, you might be deciding, well, gosh, I'm just going to use this all the time. Okay, but there's nothing that's going to say you absolutely have to use the quadratic formula in X situation. Okay. To use the quadratic formula, it is exactly that. It's a formula. Right? Formulas identify numbers that we can plug in, we plug them in, and then we plug and chug. So that's what we're doing here. There's just a lot more plugging and chugging happening. To identify our correct letters for A, B, and C, we are going to have to make sure that we are set equal to 0. Right? Yesterday when I was showing you when we were deriving that quadratic formula, the original statement that I completed the square on was something that said ax squared plus bx plus c equals 0. Okay, that was the original problem I completed the square on. So that's the format we're going to have to be in today for the quadratic formula to work. Now, just like we did with completing the square, I'm going to go through and start giving you sort of the steps to do a piece at a time. It's going to seem a little bit overwhelming and large to start with. Please do not vary from the options I'm giving you today because my students think, oh, I can just do this. It won't work throughout the next couple days if you find like, oh, I can just type in all of this and just do my square root here. So be really careful because what I'm giving you today is what's going to work consistently no matter what happens underneath that square root sign. Okay, so here we go. Let's say we have something that says x squared plus 7x plus 6 equals 0. Your first step to use the quadratic formula is going to be to identify A, B, and C. Okay, we need to decide what A, B, and C equal. If you do not pick this correctly, everything else is wrong. That's the problem with using a formula. We're not plugging the correct numbers into it. It's not going to work out. So we have to find A, B, and C appropriately. Remember, just like we said with trinomials, this is the form that says ax squared plus bx plus c. Okay, so what is our A going to equal in this trinomial? Not x squared, we just want the number. What number's in front of this x squared? 1, right? So A is 1. You will never take a letter. You are only pulling out a number. Just like in trinomials when we were factoring, right? A times C, that variable didn't come with it. Okay, what's B going to equal? 7. What is C going to equal? 6. So A is 1, B is 7, C is 6. Now, just like with anything, we might have some weird situations where we're identifying A, B, and C. So what happens if we were given this? 4x squared minus 3x plus 2 equals 0. What does A equal in this situation? 4. What does B equal? Negative 3, just like it did when we were factoring trinomials. What does C equal? 2. Good. How about 3x squared minus 11 equals 0? What does A equal?
3.
3, excellent. What does B equal?
Negative 11.
No,
Wait. No, it equals 0.
because it doesn't have the x on it. So B is 0.
Yeah.
What does C equal?
Negative.
Negative 11. So you could still use the quadratic formula on this. You would have to identify your A, B, and C appropriately. Just like with anything, the variable could change up. How about this one? 7y squared plus 8y equals 0.
7 is A.
Okay, 7 is A. What's B?
8.
8.
C is 0.
C is 0 on that one. That is actually the biggest mistake I see when it comes to the test. My students can use the quadratic formula beautifully. They don't pick the appropriate A, B, and C, then none of the rest of that work matters. So you have to be able to find A, B, and C correctly. Okay, once you find A, B, and C, step 2. Oh, that's so bad. Our second step is that we are going to plug them into the formula. So if this is our formula, right, we said this was our quadratic formula we wanted to use. Okay, and going by that original problem that we wrote down, we said A is 1, B is 7, C is 6. Okay, so we know we have A is 1, B is 7, C is 6. Okay, so we are going to substitute. What does substitute mean? Replace the letter with its new corresponding value, which means if a number goes in, the letter comes out. You should not have any variables left in the formula other than this. Okay, so we'll have x equals negative b. So what does B equal?
7.
7. So we're going to write down -7. The negative is part of the formula. The 7 is what's going in for B. Plus or minus, because that's part of the formula. Okay, long square root. B squared. So what are we putting in for B now? 7. I cannot stress this enough. There are times where we have to have parentheses for that, and times where we do not have to have parentheses for that. But just like I've always said, it's better to err and include them. Okay, so if you're not for sure, put that in parentheses, because if you're using your calculator to help you, you have to enter it correctly. Minus 4, because 4 is part of the formula. Okay, that 4 is not coming from somewhere other than the formula tells me to write it. Right? Area of a triangle is 1/2 base times height, so I include a 1/2. Times A. So what am I going to put in for A?
1.
1, so I'm going to put times 1. Times C.
So times 6.
Times 6. All over, notice my fraction bar is encompassing the whole thing, all the way across. Not part of it, not some of it, all of it. All over 2 times A. What's A?
1.
Okay, the better you get at knowing the formula, the quicker it is to plug it in. Step 3. You are going to simplify, this is the key here, under the square root. Do not, if you are using your calculator, do not type the square root into your calculator. Now, one of the biggest things I have is students who want to do it in their head. That's a great thing, but make sure you take care of order of operations. So what you cannot do is say, okay, 7 squared is 49, 49 minus 4 is 45, right? Because I can't do subtraction before I do multiplication. So my suggestion is that right now everyone pick up their calculator, because these numbers sometimes get ridiculous, especially as we go into tomorrow, and type in all of the stuff underneath the square root sign exactly how you see it. Okay, so type in parenthesis, 7 parenthesis, squared, minus 4 times 1 times 6. One long big strand, exactly how you see it. Okay, then you hit equals. What do you get? 25. Okay, so now we have something that says x equals -7 plus or minus the square root of 25, one big long fraction bar. Are we okay with me not writing a step for multiplying the two numbers in the denominator? Can I just turn 2 times 1 into 2 and not make that an individual step? Anybody not getting 25 in their calculator? We'll do some more. We're gonna practice this a lot. So let me know if you don't want to say it in front of class or something, and I'll. Okay, step 4. We are going to simplify the square root, and this is where we have to be careful. That square root will not always be a perfect square. Today it's going to be because I don't want to add anything additional to the plate. Okay, but make sure we're actually thinking about simplifying it. So I always tell my students to just check and see if it's a perfect square first. Because sometimes we'll get a number of like 4,658 underneath that square root. I don't want to start simplifying if I don't know if that's a perfect square or not. So I'm just going to check it first. All right, you can always check in your calculator. This one we should know. What is the square root of 25? 5, right? So if the square root of 25 is 5, that means that square root symbol is coming off. And so now we have something that says x equals -7 plus or minus 5 all over 2. Right? I took the square root of 25. The square root of 25 is 5. How many answers is this? 2, because it has that plus or minus in it. So that's going to be our 5th step, just like with completing the square. It's going to be to calculate both options. This is going to come with a small star. If you can. Today you'll be able to. We won't always be able to. Okay, so we're going to do the exact same thing that we do with completing the square. We are going to consider both options. Option 1 is that we can have -7 plus 5 over 2. Our second option is that we can have -7 minus 5 over 2. Now, calculator lovers, we have to be a little bit careful here. You cannot type into your calculator -7 plus 5 divided by 2 equals, or you will get the wrong answer. Okay, you have to make sure that you are doing this as 2 separate pieces. So we'll do the numerator first. -7 plus 5 is what? -2. -2 divided by 2 is what? -1. -7 minus 5 is what? -12. -12 divided by 2 is? -6. And so we will get answers of x equals -1 and -6.
Are we going to use this for like all the stuff that we did before?
Yep. So let's see what this looks like with a problem, but really quick here, I want to show you something. Okay, so Olivia, because you asked this, and I think this is something that you liked, Olivia might look at this problem on the test, and Olivia might think, I like factoring, I see factoring. Oh look, this factors into an x plus 1 and an x plus 6. Same answers? Probably less work. But, exactly, right? But how would you know that it's factorable? Well, that's a different type of brain thinking.
I saw that right away.
Right? So, right, some people will see it, some people won't. It's not a good or a bad. Sometimes Mr. O'Neill sees like freakishly factorable problems that I'm just like, yeah, whatever, I'm going to do something else. Okay, just because that's what our brains see. So again, it's not right or wrong, it's just another option you can pick from. And there would be nothing wrong with Olivia factoring on her test and getting that answer, and Drew using the quadratic formula and getting the same answer. Okay, so get another one here. 4x squared minus 12x plus 8 equals 0.
What if it isn't 0?
We'll talk about that later. We'll have to do moving around just like we did with completing the square. Okay, my guess is that a lot of you aren't going to go through factoring out a GCF and then factoring a trinomial, or factoring this the long way. This would be more that would tend to lean towards quadratic formula. Okay, so if we go through our steps, what does A equal? Does it equal 0? Yeah, that's step 1, right? We really have to make sure it equals 0. What does A equal?
4.
4.
B is
What does B equal?
-12.
-12. What does C equal?
8.
8. Okay, so we're going to start plugging into the formula. So here we go. X equals -b. What does B equal? So we want the negative of -12. What's that going to be? Positive 12? Class, really? This is really saying the opposite of B? We read it as a negative, but we have to be careful because we don't know what the sign of that B is, so we're really taking the opposite of it. Plus or minus B squared, what does B equal?
-12.
-12, we have to have parentheses here. Because that's a negative, remember we've talked about that? Minus 4. Times A. What does A equal in this case?
4.
4. Times C.
8.
8. All over 2 times what does A equal? 4. Okay, what does our next step tell us to do?
Simplify under the square root.
Right, underneath the square root. So pick up your calculator and you're going to type in exactly what you see underneath the square root. So right here. Don't type in the radical, only type in this stuff. Parenthesis, -12, close parentheses, squared. -4 times 4 times 8 equals 32. What do we get underneath the square root?
16.
16?
Yeah.
132 to 100. Yeah. Okay, so are we all getting out 16 and we agree with that?
Yeah.
So now we have 12 plus or minus the square root of 16 all over 8. So now we're going to simplify the square root of 16. Okay, so what is the square root of 16?
4.
4. We are taking the square root of the number, so the square root comes off. So now we have 12 plus or minus 4 all over 8. Do not do something with that 4. It is already outside of the square root sign. How many answers is this? 2. So option 1, we will have 12 plus 4 over 8. Option 2, we will have 12 minus 4 over 8. What is 12 plus 4? 16. 16 divided by 8 is 2. 12 minus 4 is 8. 8 divided by 8 is 1. So we get x equals 2 and x equals 1.